Good morning all. Today we're going to experiment with the single 8-channel analog multiplexer / demultiplexer, part number CD4051. Now this is a very fascinating IC because you can have 8 selectable analog inputs to one output, or you can have one input to 8 selectable outputs. It goes either way. Now I have 8 potentiometers right here, and the wings of the potentiometer are connected to a plus and minus 5 volts DC, and the wipers of the potentiometer are going to the analog inputs of the CD4051. I have a fluke DMM set to voltage mode and a fluke oscilloscope so that we can see the voltage and the swing of plus and minus 5 volts DC when I adjust the pot. They're connected to pin 3 on this IC. Now the selections of which potentiometer is voltage is brought into the IC is done with this dip switch going to pins 9, 10, and 11. It's a binary selection, so that if the dip switches are set 0, 0, 0, then pot 0 will be allowed to bring its voltage into the IC, and we will see it on the output. If we have 0, 0, 1, then pot 1 will be brought in. And there's also an inhibit. We will look at the waveforms of when we inhibit that IC and turn all the inputs and outputs off. Well, let's perform the test. Right now, the selections on pins 9, 10, and 11 are set to 0, 0, 0. And that means that we can bring the voltage from this pot to the output of that IC. Now we're going negative. There's the full swing of that potentiometer right there. And we're at negative 4.981 volts DC, and we can see we've gone close to negative 5 volts on the oscilloscope. Let's go back the other way with the potentiometer. Isn't that fascinating? Let's get close to 0. Now we're going to select potentiometer number 1 with the dip switch. Now at the end of the video, I'll put my drawings up of this circuit so that you can perform the test. It's a very simple circuit to put together. We're going positive with potentiometer 1 because we've selected that potentiometer analog voltage to come through the chip to the output with the dip switch. The dip switch being set to 0, 0, 1. Let's go back the other way. Go back up to 0, or as close as we can get. Alright. Now we're going to select potentiometer number 2. We have 0, 1, 0 on the dip switch, and here's 0, 1, 2 potentiometer. Let's get our screwdriver in there. We are moving negative with the potentiometer, applying that voltage to the input. Now we've gone positive. Let's go back to 0 or close to it. Now we're going to select potentiometer number 3, 0, 1, 2, 3. And there's 0, 1, 1. That's binary 3. That is amazing. All right. Now we're going to go to potentiometer number 4. 0, 1, 2, 3, 4. And that's binary 1, 0, 0. All right. Potentiometer number 5. 0, 1, 2, 3, 4, 5. We have 1, 0, 1 on the selection inputs. 1, 0, 1 is binary 5. That's very fast. From a change on the input to a change on the output. Now we're going to go to potentiometer number 6. That's 110 on the selection inputs. Come on, get in there. That's very nice. Very nice. Last one, potentiometer number 7. And that is binary 117 on the selection inputs. 0, 1, 2, 3, 4, 5, 6, 7. Awesome. Nice. Now, you don't have to allow this input to go negative. You can go from 0 to 5 or 0 to 10 or 0 to 15. In addition to going plus or minus 5, plus or minus 10, and plus or minus 15. Or any voltage there within, you could go plus or minus 12, but you don't have to go on the negative side. If you take the VEE pin, that's pin 7, and tie it to the VSS pin, ground, pin 8, this will only swing in the positive direction. Let me show you how that's done. We'll power down real quick. Let this power supply fully power down. There we go. Now this is pin 7 VEE, and I'm going to tie it to ground right there, and I need to tie one wing of the potentiometers to ground. See if I can find out how to do this. Let's see, I need another piece of wire. We're going to undo the green wire going to the -5. We're going to tie the end wing of the potentiometer to ground so that we're going from +5 to ground on the wing of the potentiometer. I hope I got that right. Let's find out. Okay, looks like we are. Now we're going to stay on 111 selection for potentiometer number 7. And now we go from 0 volts, because I've swung the potentiometer all the way to power supply ground, circuit ground. We're going to go the other way. And now we're very close to 5 volts, 4.965 volts DC. So if you had, say for instance, a microcontroller whose digital to analog input was from 0 to 5, this is how you would set up your CD4051. You would tie VEE to VSS. Nice. There you go. Now why? What possibly would be a reason for you to have multiple inputs to one analog output? Multiple analog inputs to one analog output. Well, let's make a few examples. Let's say that this potentiometer here, pop 0, was replaced with a current sense output. This would be current sense output number 1. And this would be current sense output number 2. And let's say that this potentiometer here was motor thermal, and then this potentiometer here was replaced with, all being replaced with a heat sink thermal. So you would have 4 analog inputs selectable from a microcontroller to bring the analog data into one analog input of the microcontroller. Now some microcontrollers have a plus and minus 10 or plus and minus 5 A to D converter, and you could allow these inputs to swing from +5 to -5 or +10 to -10. But on, say for instance, the PIC microcontroller that I use, its analog input to the A to D converter is 0 to 5. So I wouldn't want to swing negative on those. That would destroy my IC. Have I missed anything? So, current sense 1, current sense 2, motor thermal, heat sink thermal, and whatever else analog you wanted to bring into the A to D converter. A standalone A to D converter or a microcontroller's A to D converter. And these being selectable from a microcomputer or microprocessor or a microcontroller, these bits select which analog input would be connected to the analog to digital converter. Now, what about the inhibit? Right now, the inhibit is off, and we're going to turn it on. And look what we have here. Let me increase that amplitude. All of the inputs and outputs have been turned off. And you see this noise right here. That is 60 hertz from the fluorescent lighting above our head. Isn't that amazing? There's energy all around us. Let's turn the inhibit off. Zero on the potentiometer. Bring that time and voltage back down. There we go. That's a fun circuit to play with. Alright, I think I've covered everything. At the end of the video, I will put up my drawings and discuss them. Here's one of them. I'll put these up at the end of the video and we'll talk about these two pieces of paper. Okay, we're done. We are done. Let's head to the hooch. See you in a little bit. Here we are at the house. Good to see y'all again. Now, let's talk about the CD4051. I have 8 potentiometers into these 8 inputs. Here's input 7 on pin 4, input 6 on pin 2, input 5 on pin 5, input 4 on pin 1, input 3 on pin 12, input 2 on 15, input 1 on pin 14, and input 0 on pin 13. Now these 8 potentiometers, I don't show but only one. We would get all tangled up if I showed all 8, so I only show one. 20 kilo ohm potentiometer into each input of that CD4051. The wings of the potentiometer are connected to plus 5 volts DC and minus 5 volt DC. Here is the output on pin 3. And pin 3 is connected to channel 1 of the oscilloscope, whose ground is referenced back to this ground right here, the ground of the power supply, and the digital multimeter, pin 3 connected to the input of the digital multimeter, and its ground probe connected to ground of the DC power supply. The DC power supply is supplying plus 5 volt DC ground and minus 5 volt DC to the CD4051. Plus 5 volts DC to VDD pin 16, ground to VSS pin 8, and minus 5 volts DC to pin 7 VEE. Now the selection of which input is connected to the output is done with this circuit right here. For instance, when we have this input of this potentiometer and the selection is set to 111, it is connected to pin 3 of the output. Let's go over here and look at this circuit right here. Now here are the inhibit and selection inputs to the CD4051. When the switch is open, I have these three switches open. We have 5 volts DC applied to 9C, 10B, and pin 11A. So we have 1, 1, 1 applied to those selection inputs. When all of these switches are closed, we have 0 applied to each selection input. By opening and closing these switches right here, you can select which analog input is applied to pin 3 output. So for instance, all of these switches are closed. We have 0, 0, 0. And we open up this switch, remaining closed on these two switches. We have 0, 0, 1. And potentiometer number 1 was applied to the output. We close all of these switches. We have 0, 0, 0. Potentiometer 0 was applied to the output. And if we open up all of these switches, we have 1, 1, 1, and potentiometer number 7 was applied to the output, pin 3. Now, Inhibit, when this switch was open, all of the outputs were turned off. The outputs and inputs were turned off. When we close this switch, we apply a 0 logic level to the Inhibit input, and all of the outputs were allowed to connect to those 8 analog inputs to the 1 analog output. There you go. There you go. Not too hard. A lot of fun. Thank you very much for stopping by. Alright, I gotta go into the backyard and make sure that my basil and chives has got plenty of water, and fill up the bird feeders so the critters in the backyard will be alright. We'll see you next time. Enjoy your time on this side of the dirt.